The 2013 AB free response number 3, we have a table of values that represents the amount of coffee that has dripped through a coffee maker on the interval 0 to 6. They do tell you that C is differentiable, so that's important. Select values of C are given in the table above. Use the data in the table to approximate C prime of 3.5. Pretty easy thing to do. The slope at 3.5 falls between 3 and 4. So the best we can do, instead of doing the derivative at a point, the best we can do is measure the slope from 3 to 4, which would give me this. Okay, now you absolutely must write what is called the difference quotient. You have to show the change in y over change in x. While you should be able to, without any trouble, find the 4 minus 3, you need to write that down. If you want to simplify this, you can. 12.8 minus 11.2 would end up being 1.6. Divided by 1 is obviously 1.6. And then we need to include units. So we measured on top, or we subtracted on top, the ounces. So this is going to be ounces was the difference in the numerator, and the denominator was a difference in minutes. So this is ounces per minute. Is there a time on the interval 2 to 4 at which C prime is equal to 2? And I only have a table for C, so anytime you're trying to guarantee derivative values, start by thinking the mean value theorem, which states that for any function that is differentiable from point A to B, there must be a point between A and B that the slope of the tangent is equal to the algebra 1 slope from A to B, and this is the formula associated with mean value theorem. But if I'm going to use mean value theorem, we have to first establish all the criteria that allow you to use mean value theorem, which is that your function C of t is differentiable and continuous, and you must write continuous as well. Last year there was a question involving the mean value theorem, and if you did not specify continuity, then you lost a point in the justification part of it. So C of t is differentiable and continuous on the interval 2 to 4. Therefore, H, where in the world did H come from? Therefore, C prime of t must equal C of 4 minus C of 2 over 4 minus 2. And I always start by trying the going from endpoint to endpoint, because most of the time that works. C of 4 is 12.8. C of 2 is 8.8. All divided by 2. And that does end up being 4 divided by 2, which is 2. And that is the value I wanted to achieve. And so that must be true for some t on the interval 2 to 4. So there is your justification for that problem. Number C, use a midpoint Riemann sum with 3 subintervals of equal length indicated by the data in the table to approximate this integral. Now remember, the Riemann sum, or a trapezoidal, if they ask for a trapezoidal approximation, only approximates the definite integral. The 1 over 6 is not part of that. So that 0 to 6 C of t is going to be approximately, this is an approximation, the 1/6 is not part of the Riemann sum. And then I'm going from 0 to 6 with 3 intervals. So each rectangle is going to have a base of 2, and the height determined by the middle of the intervals. So 5.3, 11.2, and 13.8. So my first rectangle, a base of 2, and a height of 5.3. My next rectangle, a base of 2, and a height of 11.2. And my next rectangle, a base of 2, and a height of 13.8. And you can stop there. You do not have to simplify that. So I would actually stop there, especially since this is a non-calculator question. You don't want to hurt yourself by taking a correct answer and making it incorrect. But we do need to go a little bit further, because it does ask you to use correct units to explain the meaning of this integral. Now notice it says explain the meaning of the integral, not the meaning of the answer. So we don't have to worry about including the numeric answer in the end here. And so So this integral, you're expected to recognize that the 1/6 in front is coming from the average value theorem. So what we found in your thought process is that this is the average value of C of t on the interval 0 to 6. But you can't just say that, because that doesn't explain anything about the context of the problem. So this is really more of a thought process. We did find the average value, but what we have to do is put into words what C of t represents. And so this is the average, and the average of C, and C, they described right here, is the amount of coffee in the cup at time t. So here's your description. I usually just take it straight off the problem, the amount of coffee in the cup at time t. So this is the average amount of coffee in the cup on the interval 0 to 6. And you do have to restate the interval, because that is part of the interval as well. And you need to understand that the 0 and 6 is referencing the interval over which we are finding the average amount of coffee. And I actually have not finished this, because I just realized that I never did indicate units, and they did tell you to. So using correct units, this is the average amount of coffee in the cup in ounces on the interval 0 to 6, because C of t is measured in ounces. And then that brings us to the last question, which is independent of the table. There's my son. The amount of coffee in the cup is modeled by B of t. So here's another function that is representing the amount of coffee in the cup. And it says, use this model to find the rate at which the amount of coffee in the cup is changing at t equals 5. And so the rate that this is changing would be B prime of 5. Greg, you're making this difficult. This is B prime of 5. And to get B prime of 5, we first have to find the derivative of B of t. So B prime of t. Hey, buddy. So B prime of t is going to be, the derivative of 16 is 0. I'm going to ignore the negative 16. I'm not mama, I'm daddy. Now, this is making the last part really difficult. Okay, the derivative of e to the negative 0.4t is e to the negative 0.4t times the derivative of the exponent, which will be negative 0.4, and then B prime of 5. I'm going to make this really simple on myself. I'm going to just plug in 5 everywhere I see a t. So don't unplug that, because that's how I'm writing. So that's e to the negative 0.4 times 5 times negative 0.4. Use this model to find the rate at which the amount of coffee in the cup is changing. So I just plugged in 5 for my t's. That is your numeric answer. Please do not attempt to clean that up. Don't take my shirt off. And if you want to include units, we found the rate that the amount is changing. So that would be in ounces. Grant, they can't hear me. That'll be in ounces. And they never did restate units in this, but I'm going to assume minutes as well, because that is what the original function in the table was measured in. Woo, so there we go.